You ready, Josh? Then stop putting your head down, think happy thoughts, and be alert and awake. What a great way to finish up. Here we go. We're going to be talking about two types of chemical or two types of changes that can happen to substances. Physical changes and chemical changes. Last chemistry topic. So we have a physical change versus a chemical change. What's the difference? First of all, recall from your KMT, your kinetic molecular theory. What did that tell you? It told you that all particles are what? I'm looking for a word that begins with the letter M. Moving. In a solid, are they closer or further apart? Closer. Moving faster or moving slower? So let's just say they're closer together in a solid. Chemical bonds, these are how atoms are held together. Atoms are held together with chemical bonds. In a physical change, not a chemical change, but in a physical change, the bonds are, I'll change colors, not broken. So the particles are still the same, but the size or the shape, you know what? I'm actually showing you guys the wrong part here. You guys can fill this in, but I need to go to my PowerPoint where I have all my extra pictures and things. This is what I want it to be on. That was silly of me, Mr. Dewick. Let's go to the very top. So, what did I say? This is KMT. Seemed a little odd. I was going, wait a minute, I had a video link in here somewhere, didn't I? They are closer, we said this, yes. And how atoms are held together? Because I had a couple of videos to show you. Put your pencils down, please, look up. So I already said this. I said in a physical change, chemical bonds are not broken. So the particles are still the same, but the size or shape of the object has changed, or, and this is where we left off, or the physical state, solid, liquid, gas, has changed. So every time you go from a solid to a liquid to a gas to a solid to a liquid, those are all physical changes, but you haven't changed the particular makeup of the compound. Or if you change the size, or if you change the shape. Let me give you some more specific examples. Words, so I should also say, they often involve, because when you take energy away, an object becomes solid. When you add heat, it becomes a liquid or a gas. Some words to describe physical changes. Here's a physical change. Here's a substance. What substance is this? A piece of paper? Is it still paper?
Yeah.
Have I changed its shape?
Yeah.
So you know what? Tear. Cut. Rip. Shred. Boil. Dissolve. Can you give me some other words that might work? That you think might be physical changes?
Brew.
Brew?
Yeah.
Actually, that usually involves a chemical change because there's chemicals going on and changing. So we're going to come back to that one. Bend. Grind. Shred. Break. Freeze. Depends what you mean by destroy. Rip into small pieces, that's a physical change. Completely destroy, usually that would imply you're breaking the chemical bonds, because it's right. So I'm gonna argue with that one too. In fact, you know what? I wrote a bunch here. I think on the next page. Here's what I said: ripping, cutting, grinding, tearing, melting, sublimation. Oh, you know what? Remember that picture from way the beginning of the year? All of those words there evaporation, condensation, sublimation, melting, but those are all physical changes. Okay? We're not going to memorize all of the words, Mason. Instead, what we're going to try and do is give you a rule so that you can look at a situation and say, hey, was that a chemical change or a physical change? And we are going to give you that rule in a bit. In a chemical change, bonds are broken and reformed. But when the bonds reform, they form differently. In fact, here is the key idea behind a chemical change. This is the question I'm always going to ask. Something new is produced. There's a second question that is almost always usable, but there unfortunately are exceptions. Usually a chemical change is non-reversible. Almost always. So freezing, can you reverse freezing?
Yeah.
That's a physical change. Could I reverse this tearing? Well, with some tape and, okay, fair enough, although that's a bit of an awkward one. But most chemical changes, almost all chemical changes, there's no way to reverse it. As an example, well, let's look at some words to describe chemical change. Yes, that's the first one I was going to write, as a matter of fact. Once you burn something, it's pretty tough to easily reverse that. Another one that you may not have realized is rust. If you're combining chemicals in a vat and letting some, because like fermentation or something, that's a chemical process, absolutely. What was yours?
Bubbles, like forming bubbles.
Yes, but I'm gonna. You know what? No. That's gonna be in my notes later. But I'm gonna have to describe it more carefully because when you're boiling something, it also bubbles. So I have to. We're gonna distinguish that. But yeah, if you combine something and you notice things are bubbling, you're looking in your textbook, smarty Alec. Okay.
Destroy.
Yes. Because it's very difficult to reverse uncook something. Right? Once you fried an egg, you can't exactly unfry it. Yes.
Could you do like break? Like if you had.
I'm going to argue most things that you break with some glue and some cleverness, we can reverse that.
Like what?
So breaking is a physical change.
Oh yeah.
Is there a hand over here that I see? Okay, fine.
Destroy.
Be more specific.
Like I destroy.
I can't because that word there has too many meanings for me to say it's one or the other, right? If you're talking just about like putting, because you could say if you put this through a shredder, you could argue the document has been destroyed. In fact, that's what they would say. But I would say it's still paper. That's a physical change. Okay?
Yeah.
So I need a more descriptive or a less wide-ranging word. You know what? Here's a, oh yeah. Disintegrate? You know what? Here's some. React, that's a basic one because chemicals react. The fancy word for burn is oxidize. That the reason we call it oxidizing is fire needs oxygen. Precipitate. Matt, you gonna make it? You're looking a little, that was a long blank there. Wake up, sit up. Yeah. Okay. Combine. These are some. Mason, I said to you I was going to give you guys a question, a test. So here it is. If you are trying to decide if a change is physical or chemical, here's the question that you ask yourself. Was something new produced? If there's a new substance, something new, that's a chemical change. If not, it's a physical change. Sierra, that'll cover about 99% of the situations. Okay? So, was something new produced? If yes, chemical. If no, Physical. But then there are going to be some more clues, and this is where we're going to get into Brooks' earlier comment. So, what are some clues that can indicate a chemical change is going on? One is new solids form, except when you're freezing. So other than solidification, you'll see sometimes you can mix two liquids together, and then you shake, 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 and then you leave it for a couple of minutes, and all of a sudden you see there's something gathering. A solid is slowly drifting to the bottom. There's a fancy word for a new solid that's formed from liquids in a chemical. It's called a precipitate. That's why it's called precipitation, by the way. Precipitate. Precipitate. Let me make that bigger so you can see it easier. There. Okay. What else can indicate a chemical change? So new solids forming, because that means something new is being produced. Bubbling. What this shows is a gas is forming other than boiling. So if you're not boiling something, you want a good example? Alka-Seltzer tablets, when you drop them in water, bubbling is occurring. There's a chemical reaction going on there.
So Mr. Dick,
Or
like,
dry ice, and you put it in, it bubbles.
I gotta be fussy. Dry ice is actually going from a solid to a gas. That's a physical change.
what if like you have like a bubble bath? Would that be a chemical change?
Soap and water.
No.
The soap doesn't go back to water.
The soap is still staying soap. The water is still staying water. The water and the soap are not combining to form a new substance.
Alright.
The soap is still this is why my fallback is always, was something new produced. That will work every time.
Alright.
It's just figuring out whether something new was produced can be tricky. So clues: if I drop a solid into a liquid and bubbling occurs but there's no temperature change, something's going on. It's a chemical
What if
change.
like the color changes?
That's a great example.
Like you put like
Color change. You're leading to my next one. Okay. Another one. If there is an energy change, Mr. Dewick, you said that for a physical change, those are usually accompanied by an energy change. What I really mean is this. If you're not adding any extra energy yourself, you're not boiling it, and you mix chemicals together and they all of a sudden spontaneously start burning, that's probably a chemical change. Okay? Unfortunately, the rules are a little gray. You have to kind of really think about it. Okay? If sound or light is given off, which means somebody said explosions, yes, those are chemical changes. Absolutely. The chemical bonds between whatever the explosive was are being broken. So if sound or light is given off, some terminology. If heat is given off, we call this exothermic. Feels warmer. And if heat is absorbed, we call it endothermic. I realize these names look an awful lot alike. I'll tell you how I keep them straight. So we have exothermic and endothermic. I know enough science nerdy things to know that therm means heat, like thermometer. What's the first two letters of this word here?
X.
EX. Heat is exiting. That's an exothermic reaction. If it's not exiting, then it's sucking in heat. That's an endothermic. I haven't got a good one to remember. The EN is sucking. I mean, you can sort of say EN. Sorry?
Entering.
Oh, entering. Thank you. Wow. I've been teaching this for years and never noticed that. Thank you, Captain Obvious. That's brilliant. I'll use that, with your permission, for the rest of my teaching. So endothermic heat is entering, exothermic heat is exiting. How did I not see that? Good gosh, my brain works weird. Yeah. Okay. And so there are many chemical reactions that give off or absorb heat. Remember the heat pads that I showed you earlier this year, where you snap the little Snapple thingy and all of a sudden? Now, were those exothermic or endothermic? Okay. Those ones, though, and this is why I said, unfortunately, the rules have some gray. That's not a chemical reaction. That's a physical change, because they went from being a liquid to a solid. How do I know it wasn't a chemical change? Because also I was able to reverse them. I boil them again, they melt again, and they work again. So what type of change were those? Those were physical. Why? They were reversible. Did I have that in your notes or not? No. So this is just nerd trivia. The real one, Ibrahim, the word that works all the time is if something new is produced, it's a chemical change. The problem is it's tough to tell whether something new has been produced or whether the same old is just changing. But I'm not going to give you crazy, weird, obscure ones on your test. I'm going to give you fairly basic, obvious ones. Baking, burning, cooking, chemical changes. Ripping, shredding, tearing, physical changes. Bubbling of gases, chemical change. Okay. Exothermic reactions, I studied them before they were cool. No? Okay. Tough audience. A little bit more. We're going to start to talk, especially next year, about chemical equations. I've taught you this year how to write compounds. I've taught you how to essentially do two-letter words. An equation is a chemical sentence. I think I told you guys at the beginning of the year, the periodic table is the alphabet of the universe. Here, right here, is starting to form a sentence. So we have chemical reactions, and there's two words you want to be aware of. So the first one is the reactants. That's what you mix together. Products are what you get out. Products isn't too bad a word. That's a grade 9, in fact, probably less than grade 9 vocabulary word that you've seen before. But the fancy word for the things that you're using in a chemical reaction are reactants. Mr. Duick, it would be really neat if there was an easy way that I could remember that chemical reactions need reactants. I got nothing. Maybe you have something. When you write them, reactants go on the left side, the same way as when you're writing an equation. The arrow is a shorthand for is combined and becomes, and then the products are on the right side. So a science nerd would read this as CH4 combined with oxygen turns into carbon dioxide and 2 water molecules. Actually, a real science nerd would read this as methane, because I know CH4 also is called methane, plus oxygen. When you burn natural gas, you lead to greenhouse gases. If you're wondering, there's the greenhouse gas equation. Or if you're not burning methane, if you're burning car gasoline, this side is a bit more complicated, but it's still carbon dioxide and water, and it's the carbon dioxide that's the greenhouse gas. Okay. Mr. Duick? Yes, Brooke? For my birthday, could you show me a video of dogs teaching chemistry? Why, Brooke? Yes, I can.